All right, write the equation of a parabola with a focus of -2, comma 4, and a directrix of y equals -2. Draw the picture, memorize the formula. Y equals ax minus h squared plus k, where a equals, I'm going to be honest, I don't think we did this, so we're going to skip this one. I'll cross this out. I don't think we did that one. 26, x squared minus 2x plus 1 is f of x, g of x is x minus 3. So here we are doing compositions. So first we have a f composed g, or f of g of x. So this would be the g of x function going into the f function. So anywhere we see an x in the f function, we replace it with x minus 3. So our function f of g of x, okay, so we'd have x minus 3 squared minus 2x minus 3 plus 1. Okay, and then here, x minus 3 squared would be x minus 3 times x minus 3, so that's x squared minus 6x plus 9, and then we distribute here, so minus 2x plus 6, and then plus 1. Combine our like terms, so x squared, negative 6x, negative 2x is negative 8x, 9, 6, and 1 is 16. So this would be f of g of x. Now for letter B, we want to do g of f of x, so that's the f function going into the g function. So anywhere we see x, we will replace it with x squared minus 2x plus 1. So g of f of x is x squared minus 2x plus 1 because of this x, and then minus 3. And then we just combine the like terms, which is just the 1 and the negative 3, so that's negative 2. And this is our composition function. And then for letter C, g of f of negative 2. Okay, so that means negative 2 gets plugged into the f function, and then whatever that is gets plugged into the g function. So let's plug negative 2 into the f function. So that's negative 2 squared minus 2 times negative 2 plus 1. That's 4 plus 4 plus 1, so that's 9. And then I'm going to plug 9 into the g function, so g of 9, which is 9 minus 3, which is 6. So g of f of negative 2 is equal to 6. 27, factor. Remember, okay, so this is a difference of two cubes. Okay, 8x cubed minus 27. So the first cube is 2x to the third power, and the second cube is 3 to the third power. So we would use our formula for a difference of two cubes, and this is the formula. This has, it's a minus b, a squared plus ab plus b squared. In this case, 2x is a and 3 is b. So this would factor into 2x minus 3, and then 4x squared, because 2 squared and x squared, and then ab, so a times b, so that would be plus 6x, 2x times 3 is 6x, and then plus b squared, so b is 3, so b squared is 9. So this would be the factored form for 27. Number 28 is a sum of two cubes, 125x cubed plus 64. Okay, so the first cube is 5x to the third, because 5 to the third is 125, x to the third is x cubed, and the second cube is 4, because 4 cubed is 64. So here's the formula for a sum of two cubes, so it's a plus b, so 5x plus 4, and then a squared, so that's 25x squared, because a is 5x, minus a times b, so 5x times 4, so that's 20x, plus b squared, b is 4, so that's 16. So this is our factored form for 28. 29, describe the end behavior. Okay, so the end behavior had to do with two things, the degree and the leading coefficient. Okay, so we could have the degree could either be even or odd. The leading coefficient could be positive or negative. So if it was even and positive, this was the end behavior. If it was even and negative, this was the end behavior. If it was odd and positive, this was the end behavior. And if it was odd and negative, this was the end behavior. Okay, so positive, the right side always goes up. Negative, the right side always goes down. And then even, they both go in the same direction, up or down. And then odd, they go in opposite directions. So first we determine the degree. The degree here is 3. So that's odd. And the leading coefficient is 2, which is positive. So it's odd positive, so it's going to have this end behavior. Okay, so as x goes to infinity, so that's on the right side, the function also goes to infinity because the right side will go up. As x goes to negative infinity, which is the left side, the function also goes to negative infinity because the left side will go down. Describe the end behavior here. Okay, so even with a negative leading coefficient. So that's actually this one. Both sides are going down. All right, because it's negative leading coefficient, so the right side goes down. Even degree, so the left side does the same thing, so it also goes down. So on the right side, so as x goes to infinity, the function goes down, so negative infinity. And then on the left side, as x goes to negative infinity, the function also goes down, negative infinity. Number 31, is x minus 3 a factor of the polynomial x to the fourth minus 4x cubed plus 4x squared plus 8x minus 33? Show your work and explain. There's a couple of ways to do this one. I'm just going to use synthetic division, because if x minus 3 divides into that, then it is a factor. Okay, so if the remainder is 0 when I use synthetic division, then it's a factor. Okay, so I just need the coefficients. So 1, negative 4, 4, 8, and negative 33. And the number I'm using for my synthetic division is the 0, so it's going to be positive 3. The 1 comes down, so 3 times 1 is 3. Negative 4 plus 3 is negative 1. 3 times negative 1 is negative 3. 4 plus negative 3 is 1. 3 times 1 is 3. 8 plus 3 is 11. 3 times 11 is 33. Negative 33 plus 33 is 0. Okay, so yes, x minus 3 is a factor because the remainder is 0. Or because it divides evenly into the polynomial. Number 38, find the remainder. Okay, so this is the same thing. We're just using synthetic division here, okay, because it's asking for the remainder. So it's just asking the same thing, slightly different way. So the coefficients are 1, negative 5, 1, and negative 10. The number I'm going to use is negative 2, because that's the 0. The 1 comes down. Negative 2 times 1 is negative 2. Negative 5 plus negative 2 is negative 7. Multiply these together is 14. Add these is 15. Multiply those is negative 30. Add those is negative 40. So the remainder would be negative 40. If x plus 2 is a factor of x cubed minus 2x squared minus 20x plus k, find k. Okay, well, all I need to do is make sure that the coefficient, or I mean the remainder, is 0. So let me just set up the problem. 1, negative 2, negative 20, and k. I just got to make sure that this k value will cause the remainder to be 0. Okay, so I'll set up negative 2 because that's my 0. So 1, negative 2 times 1, negative 2, and then add those is negative 4. Multiply these, whoops, negative 2 and negative 4 is 8. So add these, negative 12. So negative 2, negative 2 times negative 12, that's 24. Okay, so in order for this to be 0 here, my k, that would have to be negative 24. So k would have to be equal to negative 24 for the remainder to be 0 here. Use synthetic division to divide. Okay, so just some more synthetic division problems here. But they do want to know what I actually get when I do the division. Okay, so I'm dividing this polynomial by x minus 3. So I got 6, negative 8, 7, negative 3, and then the 0 is 3. Okay, bring down the 6, so multiply those, that's 18. Add those, that's 10. Multiply those, that's 30. Okay, that's right. Right. So squared, yeah. So 18, 10, 30, 37. Okay, getting kind of big here. So 37 times 3, 111. And then add those, so that is 108. Okay, now it actually wants the quotient, or the quotient, what I end up with. So remember the way that you do this. This is the remainder. This would be the coefficient. This would be the constant. This would be the coefficient of the x, and this would be the coefficient of the x squared. The remainder always goes over what you divided by. So I have 6x squared plus 10x plus 37 plus the remainder over what I divided by x minus 3. Okay, so when you divide this by x minus 3, this is what you get. You could have also used long division for that, but it said use synthetic. Okay, solve log. Solve the log formula. Okay, so first I need to isolate the log part. So let me add 4. So I got 2 times log base 3 of 2x plus 5 is equal to 18. Okay, I need to get rid of that 2, so divide by 2. So log base 3 of 2x plus 5 is equal to 9. Okay, and then I need to change it to exponent form. Okay, so changing this to exponent form, 3 to the 9th power is equal to 2x plus 5. So let me evaluate what's 3 to the 9th. Whoa, huge number. 19,683 is equal to 2x plus 5. And then I can solve this for x. So subtract 5 and then divide by 2. So 19,678 equals 2x. Divide by 2. So 9,839 would be the answer to that. That seems a little big. Did I put that in correctly? It's 3 to the 9th power. Yeah, it's 19,000. So, yeah, seems good, I guess. Consider the graph of the following polynomial. Which of the following equations models the polynomial function above? Okay, so there's a couple things I need to make sure of. First, I'm going to look at the end behavior. Okay, so the end behavior is going down on both ends. So not only is it even, should have an even number of degrees, it also has a negative leading coefficient. Okay, so right off the bat, I'm going to eliminate letter A because it has a positive leading coefficient, And eliminate letter C because it also has a positive coefficient. Okay, so all three of these have a degree, or all two of these have a degree of 4 because it has an x plus 2, 2x minus 1s, and this one has an x, and 2x minus 2s, and x plus 1. So they both have a degree of 4. They both have an even degree. I need to look at the zeros. So it passes through here, so it has a 0 at 1, it has a 0 at 0, and it touches 2. I don't know if we discussed this a lot. I think we did, but when it touches a point and doesn't pass through it, then it is going to have repeated degrees there, okay, or repeated zeros. So at the x minus 2 factor, it should have multiple, and it does. It has 2 of them. So this is the correct equation. Number 37, which function matches the graph? Okay, so there's a couple of ways to do this. The easiest way would be to use transformations, okay, because we know that this is a square root function, and we know that the normal square root function is here, because 0, 0, 1, 1, 4, 2, this is the normal square root function. Okay, so using transformations is going to be the easiest way to tell how to get from this to this, okay? Because we can see that it's moved 1, 2, 3, 4, moved 5 down, and it's moved 1, 2, 3, 4, 5 to the right. Okay, so we need to look for the one that has a shift down 5 and right 5. Okay, so down 5 would mean it has minus 5 on the end. Okay, so this one's wrong because it has plus 5 on the end. That's a shift up 5. This one's wrong because it has a shift up 5 as well. So both of these have a shift down 5. Now we need to look at where the x is, and remember that one's going to be opposite. So if we're thinking that we're going to the right, that's typically positive, but it's going to be opposite. So it's actually this one. Square root of x minus 5 minus 5. That's a shift right 5 and down 5 from the parent function. Square root of x plus 3. Okay, you can use what we just did on the previous problem, transformations, to do this problem, because plus 3 would be a shift to the left by 3 of the parent function. And there's only one of these that's shifted left by 3. It's letter C. Find the zeros, then graph. Okay, well the zeros are easy for this one. Okay, so there's each factor has a 0. So there's a 0 at x equals 0, there's a 0 at x equals 5, and there's a 0 at x equals 2. So we're looking for the one that has a 0 at 0, 5, and 2, so that's letter B, and you can see them 0, 2, 5. You can see all of the zeros. Number 40, identify the logarithmic form of 3 to the 5th equals 243. So that would be, so remember what a log says? It says the base to what power? So that would be log base 3 of 243 is equal to 5. And that says 3 to what power is 243? Well, 3 to the 5th power is equal to 243. So that would be letter B. 41, solve the log equation. Okay, so pretty straightforward here. We are going to change this to exponent form. So remember, this is a common log. It has a base 10. So this would be 10 to the second power is equal to 3x plus 10. Okay, so that's 100 is equal to 3x plus 10. And then we can solve this for x minus 10. 90 is equal to 3x. Divide by 3, so x is equal to 30. So letter A. 42, which the following represents a shift of 5 units right, 6 units up of log x being the parent function. Okay, so remember when you're doing transformations, transformation shifts left and right should go on the inside with the x, and shifts up or down should go on the outside. So I know it's 6 units up, so it's going to be plus 6 on the outside. It's 5 units right, so that's going to be minus, because it's opposite for the left and right, so it's minus 5. So that should be log of x minus 5 plus 6. That's letter D. Number 43, an initial population of 650 quail increases at a rate of 2.5%. Write an exponential function to model the quail population. Okay, so that's y is equal to a times, this is exponential growth, so y is equal to a times 1 plus the rate to the x power. In this case, the rate is 2.5%, but you have to change that to a decimal, so it's 0.025. So if we want to represent growth, we add that to 1. So that would be a, which is the starting amount, so 650, times 1 plus 0.025, so that's 1.025 to the x. So that is letter B, and that's an exponential equation. Rewrite in log form. Okay, so we learned this in different ways in different classes, but an exponent on one side would be a log on the other side. So this would be log base 25 of 1 over 5 is equal to x. And that essentially says 25 to what power is 1 over 5? That would be x. 25 to the x power is 1 over 5. So log base 25 of 1 over 5 is equal to x is right here. Number 45, solve the equation. X minus 15 to the 3/4 power equals 27. Okay, so it would be easier to write this as a radical. So this is actually x minus 15 to the 3rd power, and we're taking the 4th root of it, and that's equal to 27. Okay, because remember, rational exponents, the denominator of the rational exponent is the radical. Okay, so if we wanted to solve this, we would first have to raise both sides to the 4th power to get rid of the 4th root. So that would leave us with x minus 5 to the 3rd power equals 27 to the 4th, which is a massive number. It's 531,441. And then to get rid of this cubed, we would have to cubed root both sides. So we'd have x minus 15 equals the cubed root of 531,441. But I do think that is going to come out to an even number, or it's going to be a perfect cube. So let's see if that'll work. We want to take the cubed root of 531,441. Wish I had an actual calculator here. Five, 3, 1, 4, 4, 1. Okay, so the cubed root of that is 81. So this, we end up with x minus 15 is equal to 81. And then we add 15, so x is equal to 96. So A, 96. 46, if there are initially 2,200 bacteria in a culture and the number of bacteria triple each hour, the number of bacteria after t hours can be found using the formula And how long will it take the culture to grow to 60,000? So we want this y, the number of bacteria, to be 60,000. So we have 60,000 equals 2,200 times 3 to the t. And we're solving this for t. So we need to get the exponent part by itself. So I'll divide by 2,200. So 60,000 divided by 2,200 is 27.27 repeating, so I'll just round it off there. It's 3 to the t. And then I need to change this to log form to do this. So I have log base 3 of 27.27 is equal to t. Okay, so I can calculate this using change of base formula. Common log of 27.27 over common log of 3, and that will give me the time. So common log of 27.27 divided by common log of 3, and that gives me about 3.01 hours for that one. State the family of functions the graph belongs to, then write a function to model the graph. Oh, we're going to take a pause right there, actually.